How do hash tables work? Let's find out the answer to this most commonly asked interview question in this video. So first and foremost, what is a hash table? Simply, it's just a data structure that can map keys to values. What makes this data structure so important? The very fact that you can look up data in constant time, that is O of 1, makes it a favorite for the interviewers as well as the candidates. So how does it work internally? Internally, it's an array of buckets or slots. As you can see in this example, the hash function takes keys as the input, and the output of the hash function is the index in the array of buckets or slots. So you might ask, what is this magical hash function? Well, I would like to tell you that you don't really have to worry too much about its implementation details. All you need to know that the hash function's job is to distribute the entries across the array of buckets or slots. In an ideal world, your hash function is perfect and no two keys return the same output ever. However, the real world is usually more cruel. You might have certain keys which might give the same output. These conditions are called collisions. So, what do we do in such cases? There are two primary techniques for resolving collisions. The first one is called separate chaining, and the second one is called open addressing. What is separate chaining? Let's understand this with the help of an example. In separate chaining, each bucket is independent and has some sort of collection at each and every index. The most common implementation under this technique is separate chaining with linked lists. As you can see in this diagram, each bucket is just a reference to the head of the linked list. So suppose we got coach for dev as the first entry. This entry is mapped to index 3 in the bucket. Now what happens is this bucket is pointing to the linked list, and the first element of the linked list, what we store is coach for dev as the key along with the value that it's supposed to have. Next, suppose we got John and Alice. So we follow the same process. We apply the hash function to the keys and they are stored in the first element of their respective buckets along with the keys and the values. Now comes the interesting part. Bob's key is also mapped to index 3, which is same as it was for coach for dev. So there is a collision. We find out that the first element is already filled with coach for dev key and along with the associated value. So what do? We create a next element in the linked list and we store Bob as the key along with the corresponding value. So in this technique, if we have to do a lookup, suppose you input John as the key and you want to look up its value, what do? We apply the hash function, we get the corresponding index, we go there and we see the first element of the linked list. If the key matches, then we return the value. In case of Bob, similarly, we apply the same way. We apply the hash function on the Bob and we find out that it's at index 3. So we go to the corresponding linked list. We compare the key with the first element. We see that the first key is the coach for dev, so it's not a match. So we go to the next element in the linked list, which is Bob. Bingo, we found our Bob and the corresponding value is returned back. So in this example, we saw that how each and every bucket is just pointing to a reference to the first element of the linked list. So there is a certain improvement that we can do. Instead of just storing the reference, we can actually store the first element of the linked list itself on the bucket. This technique is called separate chaining with list head cells. Under this technique, in case of collisions, suppose in our example, we have Bob. Bob is mapped to again index 3, and since the bucket is already filled with first element, that is coach for dev, what do? We create a new element on the linked list to which this coach for dev is pointing, and we store the key and the value pair right there. Similarly, when we look up for Bob, we follow the same technique. We go to the bucket, we see if the key matches the first element. It does not in our case. So what do? We just jump on to the next element in the linked list and as soon as there is a match in the key, we return the associated value. So this technique is a little faster than the previous technique because you have one less hop every time. Secondly, this might also help with better caching efficiency since they are stored in contiguous memory locations. Now let's talk about the second technique for collision resolution called open addressing. In this technique, all the records are stored in the bucket itself. There are various probing sequences that you can follow, like linear probing, quadratic probing, double hashing. In my example, I'm gonna follow the linear probing sequence. When we added the first three entries, the corresponding buckets were empty. So we added the corresponding key value pairs on the bucket itself at their respective indexes. However, in case of Bob, we saw that there is a collision at index 3. So what we did is we started looking up for the next available freed up slot. We found out that index 5 is empty, so we stored Bob there. Similarly, in case of lookups, we follow the same process. When we are looking for, suppose, coach for dev, we apply the hash function to the key, and we find out that at index 3 the key exists, so we return the corresponding value. For John and Alice, same way it happens. For Bob, we map to index 3 again, and we see that the key does not match at index 3. So we follow the linear probing sequence. We go to index 4, the key does not match. Then we go to index 5, the key matches, so we return the key value pair from index 5. Another important thing that I would like to discuss when I am discussing about hash table in the interviews is something called load factor. As you can see in the diagram, it is just simply the number of buckets that are occupied versus total number of buckets. As the load factor grows larger, the hash table becomes slower. If you have described this much in an interview about hash tables, I would say that you have successfully answered the interview question. I'll be covering more such interview questions and answers in my upcoming videos. So please subscribe to my channel, Coach for Dev. Until next time, happy coding.